All right. So what we're doing today is we're going to be factoring. By factoring, I mean taking apart numbers and splitting them into their most smallest pieces that we can make. Like 42. 42 can be split into 6 times 7. But see, that 6 can also be split into 2 times 3. Our goal today is to be able to take these numbers and split them up into their prime factors. That's why this is called prime factorization. Same thing with 9x squared. 3 times 3 is 9, and x times x is x squared. Therefore, the factors of 9x squared are 3 times 3 and x times x. Same thing with this 56 here. Some people are really good at division and go, 7 and 8. 8 can be divided by 2 to make 4. 4 is just 2 times 2, so it's 7 times 2 times 2 times 2. Me personally, I like going 56 is even, divided by 2. That's 28. Divide that by 2. That's 14. Divide that by 2. And I get 7. Our goal at the end of this is to be able to then pair these numbers up and go, okay, how many of you guys have a pair you can go with? Well, I got a 2 and a 2. That's one pair. They go together. I got a 2 and a 7. Well, this 2 doesn't have another 2, so he doesn't go with anybody else. The 7 doesn't either. And so when I go to write this, the 2 times the 2, I take that 2 that it is, and I put it in front of the square roots. And then that 2 times 7, it literally just stays as 2 times 7 underneath here. 2 times 7 happens to be 14. So 2 times the square root of 14. We want it to look like this because when we look at our quadratic formula, we're actually going to have to be able to divide out some factors. The quadratic formula, you don't have to write this down. It's kind of a beast, but it is negative b plus or minus the square root of b squared minus 4ac, divide all of that by 2a. Now, notice, if I had been using 56 and I had the square root of 56 up here, factoring out those 2's would allow us to divide by 2 and make those numbers quite a bit smaller as the answer. And that's why we're trying to do this, okay? So you don't have to write that formula down because that formula is what we're talking about on Monday. Let's just practice writing down how to solve these ones today, how to break these apart into their more smaller numbers or prime factors here. So for 1080, I can actually factor this by recognizing, it is even. Again, you don't have to do much more than recognize that it is even. Because if you know that, you go, it's just divisible by 2. 1080 divided by 2 is going to be 540, which is also even. So it can be divided by 2, which is going to give me 270, which is also divided by 2, which is going to give me 135, which is not even anymore. I'm just running out of room. I apologize. 135 can be divided by 5. And when I do, I'm going to get 27. 27 can be divided by 3. And that's 3 times 9, which can also be divided out to be 3 times 3. Notice that thing I gave you up above, that long sequence of numbers. I do have my 5 here, my 5 there. I've got 2 3's. I've got 2 3's here as well. I've got 3 2's, 1, 2, 3, and 1, 2, 3. This is what my prime factorization is going to be. It is the 5 times 3 times 3 times 2 times 2 times 2. And then I go, okay, look, guys, I have how many 2's? 3 of them. Okay, 1, 2. Those pair up. They go in front of the square root symbol. You know what? I've got those 3's. Those 3's paired up. Those also go in front of the square root symbol. And sadly, this 2 doesn't have another 2 to go with. And this 5 doesn't have another 5 to go with. So they stay underneath of this. right here. I don't know why it says a 3. I'm going to fix it right now to be a 2. I apologize. That 2 is going to be from that one here. That is going to be what goes underneath. That means I've also got to make one more fix on my screen. It'll be fine on your papers, though. It'll be 6 because 3 times 2 is 6. And then that 2 times that 5 is 10. Therefore, 1080 is the same as 6 times the square root of 10. And again, we're going to be able to simplify out as we get more division. Let's go ahead and let's practice with some of these examples at the bottom of the page, like this first one here, where it says it's the square root of 8. Again, when I think of 8, I think of it being even, and so I can divide it by 2. 8 gets split up into 2 and 4. Oh, that 4 can also be split up into 2 times 2. From there, I say pair up. 2 times 2 is 1 pair. So that 2 goes in front. That 2 gets multiplied by the square root of that other 2 that got left from earlier. The square root of 8 is 2 times the square root of 2. What I'd like you to do is I'd like you to do the same thing with this 243. I'll give you a hint. Your first factor is going to be 3. How do I know that? 3's got its own property. 2 plus 4 is 6, plus 3 is 9. 9 is divisible by 3, so this number here is divisible by 3. Take your 243, divide it by 3, and then let's see what you guys get. I'd like you to go ahead and factor this all the way out as well. I'd like to see what your prime factorization is, and I'd like to see what your square root is afterwards. I'll show you what I'm expecting. 243, like I said, if you split it up into 3 and you divide it out, it's going to be 81. That 81 can get split up into 3 times 27. That 27 can get split up into 3 times 9. And that 9 can be split up into 3 and another 3. This is going to be my factor tree, okay? And it looks like a factor tree because like a Christmas tree where it kind of climbs its way up like this, it is another way for us to track it. Now, again, we're looking for pairs. 3 and 3 become one of my pairs. I've got another pair of 3s here and here. So I got 3 times 3. That last 3, though, is sad because he doesn't have anybody left to partner up with. So he stays underneath the square roots. My answer here is going to be 3 times 3 is 9 times the square root of 3. And that's what I'm looking for from you today. I'm going to do one more example with you guys, just one more of these 3. I'm going to have you try those 3. Okay, and that part is blank. I can fix that real quick. It'll just take me a second to get that copied off of the notes and get it for you real quick. It is the square root of 20. I'm actually going to go with the one beneath it, 720, because I think square root of 20 should be easy enough for you to be able to do. So if we're taking the square root of 720, our goal is to, again, start splitting it up into its smaller pieces. 720 is an even number, so when I go to divide it, I'm going to get 360. That 360 is an even number, so it is divisible by 2, and 180. Oh, 180 is even. That could be divisible by 2 and 90, which is an even number, which is divisible by 2 and 45, which is also divisible by, well, not 2 because it's not even, but it is divisible by 5 and 9. Hang on a second. That 9 is divisible by 3 and 3. And I can work my way down here. Again, I don't care about these big numbers on the inside. I care about those small numbers that we looked at as we were doing the dividing. What was it able to be divided by? By 2. Okay, 2. By 2. But that 2 doesn't have another partner. That's not good. I can't do anything with this 2 because it doesn't have a partner. This 5 either. I can't do anything with. They don't have a partner. These 3s have a partner, though. I get 2 times 3. Oh, by the way, that 2 and that 5 that didn't have partners, they stay underneath the square root. 2 times 3 is 6. So it's 6 times the square root of, 2 times 5 is 10. 6 times the square root of 10 is the answer that I'm looking for. If I can get y'all to go ahead and answer those last 3 on these notes and then complete the worksheets, I would greatly appreciate it.